Analyzing the graph of a quadratic function. Today, we're going to be looking at all of the different things you can see on a quadratic graph. The first thing we're going to talk about is a quadratic equation. You can see a quadratic equation written three ways. The first is standard form, which looks like how we saw it last week when we were factoring trinomials before they were factored. The second is factored form, which is written as two binomials after we factored it. And the last one we have not seen yet is called vertex form. What makes something a quadratic equation is that it has x raised to the second power. You might not notice in the factored form that you have x to the second power, but if you multiplied x times x, you would get x squared. All of our quadratic equations will be in the shape of a parabola. A parabola is the set of all points equidistant from a given line and a given point not on that line. For example, notice these 2 points are equidistant or equally as far from the middle line. Another way to think about it is a U-shaped graph. The U can be opening upwards like it's pictured here, or like I'm drawing it now, facing downwards. The vertex of a parabola is the highest or lowest point of the parabola and is named as an ordered pair x, y. Here in this picture, the vertex is a maximum, the highest point, and in the second picture, the vertex is a minimum, or the lowest point on the graph. In this graph, here is our vertex. We can name it as an ordered pair 1, negative 2, and because it's the lowest point on the graph, we'll call it a minimum. The axis of symmetry is a line that divides the parabola into two halves, and it passes through the vertex. So if I draw a line cutting this parabola right in half, that line is my axis of symmetry. I name the line using the x value that it passes through. X equals 1. Remember, 1 was also the x value of my vertex. The domain is the input of a function or the x values. So if I had a function f of x equals x squared, I can plug any x values into that equation. For that reason, the domain of this graph or any quadratic function would be all real numbers. Range is the output values of a function or the y values. So if I have a basic quadratic function, f of x equals x squared, and I plug in 2 squared, my y value or my output would be 4. You can find your range by looking at the graph. Notice the graph doesn't go below negative 2. So it's all of our y values greater than or equal to negative 2. The x-intercept of a graph is also called the roots or the zeros, and this is where the graph crosses the x-axis. When we look at this picture, our graph crosses the x-axis twice at 0 and 2. The y-intercept is where the graph crosses the y-axis. This graph crosses the y-axis at 0. You'll see some pictures where it doesn't cross the x-axis at all, and we'll talk about those roots later. Go ahead and try it. Read the directions and try the problems on the back of your notes. When you think you are done, raise your hand to have your problems checked, and then you'll receive your homework.